Good evening. This is Onyx. Jesse gonna be over here playing with the TryHackMe Advent, doing days 9 and 10, which are the networking ones. The first ones for that. Might do day 11 to see how long it takes me to go through the two things. But if you don't know what in the world I'm talking about, we are doing this right here, which is the Advent Cyber 3, which is cybersecurity in 25 days. There are 11 challenges out right at the moment. This is the 11th one. Not much the video at the moment, but there's the 11th one here. So if you have not seen the challenges, I'm going to quickly go through the start here to talk about real quick. But anyway, so this is TryHackMe. It's a beginner-friendly security exercise every day leading up to Christmas as an Advent challenge with security challenges. Unfortunately, no chocolate. I would take coffee anyway, but no chocolate. There's over 9,000 worth of prizes. For each task you get correct, you get a raffle ticket on the 26th, day after Christmas. They'll choose winners. And here are some of the stuff here. So it's OSPC courses, some hard drives, other certification stuff, Hack 5. And there's a whole bunch of people that have helped contribute to it. Down here. Alright. And then you have these. So we're doing network right now. There's a bit of web exploitation. OSINT. Oh, they haven't done any OSINT yet. No OSINT. Not yet anyway. Some cloud hacking. And some defensive blue team stuff. So, but if you haven't had a chance to do this, highly recommend starting it out. Watch all the videos. Every day has a video that posts that shows you how to do it. Oh, this is more of that. This is also the main page. So if you go down here, story. So this is the story it follows. All right. And so it looks like McSkitty, I guess. Don't know. All right. Large office of cocoa. Let's see. Assistant manager of Christmas last year. She's been promoted to the chief information officer. Then it goes on. Let's see. And of course, they get hacked. It was all planned. How do they access their internal systems? And then you go into the web exploitation, which I will not be doing, but there is several web exploitation of different styles and types. And then this by John Hammond. Each one, like this one is a walkthrough right here. Goes more into the challenge. They talk about it. This is actually pretty cool. It's usually shell bags. Pretty neat challenge. But it's more of a digital forensic style challenge than a normal that you normally would get. Actually, I can think of it. Oh, there's not even forensics up here. Well, I guess defensive blue teaming. Don't know. Anyway, so we're gonna skip all the way down here. So what we're gonna do is day 9, and this is where is all the data going? This is by yeah, I'm not even gonna try it, but he's the one that's a video here if you want to try it. Anyway, Miss McSkitty recently found out that a large amount of traffic is entering one system on the network, and they use traffic analysis skills to determine which kind of activities the Greenwich enterprises are performing. So generally, I haven't read this over yet, so I'm going to read through it real quick. So generally, there's going to be some information that tells you what you're doing and how to do it. And I'm actually going to do it on Wireshark on my computer for the first challenge, only because you have to download the file. And it's just a lot easier to just download it on my computer. So Wireshark. Right, if you have not seen Wireshark, this is the main page. So Wireshark is a packet. It's a network packet analyzer. It captures packets data as much as possible, which we'll see this in a second. So it can capture all of your traffic and display it back to you. Just remember that it can be a lot of traffic. Now I'm looking at the one I downloaded earlier for this challenge. It is, let's see, 5,208 packets. How big is that? Shoot. I didn't save it right. I'm not sure how big it is at the moment, but I'll check it in a second. But so just that one packet alone. It's a measuring device to examine what's happening inside a network cable. So if you ever do any type of network stuff, want to know what's going on in your network, this is the best way of doing it. Is using using Wireshark. There are other tools such as TCP dump, which is a command line tool, T-Shark, which is Wireshark's version of TCP dump. There's also NetWitness, and if you want to get into more like defensive style, there's Zeek and Rita and all these other tools that can also help as well. Wireshark is like the basics. If you want to get a quick, especially if you have small captures, throw it in a Wireshark and you can take a look at it real quick, see what you can find. If you're not sure what's in the capture itself. All right. So this is very expensive proprietary, and this is available but for free. All right. Some things you can do with it: you can troubleshoot network problems, exam security problems. You can use it to verify network applications, debug protocol implementation. Can't talk apparently. And then learn network protocols internals. I've done this before. This is always fun. And it's available just about everywhere. Just quick shot. So this is a screenshot of the page with this packet capture, which is actually this one's 10,299, shown in this screen. You can do live captures. The other thing with this is you actually capture over USB if you so choose. It actually when you install the driver to capture network traffic, you'd also install the driver to capture over USB devices. I've actually never done it, but I have seen one CTF that actually had data across the USB you were using captured by Wireshark. And you had to use Wireshark to view it. Oh, that's the overview of Wireshark. Alright, so we're going to do some packet analysis. Alright. So we're going to do various protocols for unencrypted traffic for HTTP, DNS, and FTP. Alright, unencrypted is pretty standard. A lot of these CTFs, you can do encrypted traffic. I'm not going to go too much into it. You basically have to capture your TLS or SSL keys, put them in a Wireshark. Your Wireshark will automatically decrypt the traffic. But this is unencrypted, so that makes it much easier to view the traffic. Alright. And in network concepts, these are some stuff you need to know. Okay, let's see. More of that. Anyway, this is a packet capture that I capture is named this. Alright, if you're in the attack box, you can use it's located here. Alright, and then this is how you would run it in the attack box. Alright. So generally, this is the interface of Wireshark. It's pretty easy. You have the command menus, your display filter, a list of captured packets, your detail for each packet, and then the hex. This is the default layout. There are a whole bunch of like tweaks and stuff that you could actually get into really doing some crazy stuff with this. but that's going to be a whole video by itself if you want to learn that. So filters, these uses the Berkeley packet filter to display them. And here's an example here. This basically says any packet with an IP address of 172.21.2.116, that's either sending or receiving. So it's either or source to destination, which terminology you want to use. But this is meaning either side. And they show the one packet. You can also specify a protocol type. So HTTP is a protocol. You can just type it in there, and then you can get all that information as well, as shown in this other screenshot. And this is basically HTTP contains google.com, which now it's listed down here. You can also do by port. All right, so there are a lot of port numbers. Actually, I put my book up. But I have a book that has a whole bunch of them in it. And I think well, this doesn't list. Nope, the Blue Team book doesn't list the port numbers in it. I thought it might, but the operator's handbook, which I will probably throw a link in the when I post it up on YouTube, with that, because that's a really good book for that. However, this one looks like I might list some of them. Yeah, so this book is the Blue Team Handbook Incident Response Edition. It's another it's written by Don Murdoch. But this one actually lists common ports in it as well. What's interesting about this book, it actually has some information about each port for email traffic, DNS, web traffic, and all that in this book, which I might also link to this book below as well. But the operator's handbook, which I do not currently have on my desk, I must put it up. I'll link to it below, but it's called the operator's handbook, and it has a full list rundown that you can just go through for all these ports. And then the other issue here is this was TCP. This is actually a remote desktop. It's 3389. And then you're seeing the remote desktop session here. UDP, you would put UDP here, port, and then we put that port there. You do a UDP port. All right. And next question is why it's not IP.port, because IP actually doesn't have port numbers. It's actually going to be not in the networking layer. So you got to use TCP or UDP and then the port number. And actually, so one of the things about this layout is it doesn't list the port numbers, which will be useful inside of Wireshark. I might add that in here when I do it. And then you can use not here to not show. You can also use a exclamation point or a bang to not show certain ports. All right. So let's see, what do they want us to do? All right, open that. All right, so it looks like we're going to be looking at HTTP GET traffic. And then traffic, use Wireshark to make it easier. This shows you all your HTTP traffic here. All right, so there's a couple things here that they show GET statements. Let's see. Just swap over to actually pull up Wireshark here. So Oh, so the other day I was playing with this. So I actually had destination port right here, which would be useful. I was working on a challenge and ended up having the destination port listed. So this is going to be your source, destination, protocol, and link. Now, you're going to notice in my screenshot compared to this one, the time is different. This is time in UTC. All right, instead of having the time here, which let's zoom in here. Whoops, that didn't work. Let's see what's up. So you notice as I'm zooming in here, this time it says 4 dot whatever. This is the time for the start of the packet, not the time of the packet itself. So this is relative time. I'm not going to get too much into it, but if people want to know specifically how to configure this, I just changed the column information to show specifically exact time. So you're looking at here going, okay, 11:08:221. It's at 17:37:30 UTC. These are where this traffic came down. You can get this out to milliseconds if you want. Not sure how useful that would be for milliseconds, but you could. All right, so you have destination port, 80s, of course, a web server, the protocol itself, the linked, and then you have get, which is your HTTP verb, the page I went to, which is /logon, and then which HTTP version 1.1 is common. All right. Now, it doesn't show the domain up here, but if you come down here, so you have the user agent here, TryHackMe user agents, and then it's right here, it's full request is right here, HTTPS 10.10.10/logon. So this is your going to be that destination. So even though this is bit by HP or by the IP address, you can still look down here, and this could say a domain as well if it's by domain, but they're pulling it by IP address. So now we can follow. Now it says specify HTTP methods. Now what they want us to do is filter this even more. Well, now get all the get methods here. Now this verb for get is the common verb. I mean, every time you go to a website, they'll get requests. And then now you have the secondary, which is post request. Okay, so get, all right, is what it's doing right now. All right, when you go website, usually it's a get. It gets that information, and you can tell from right here. You know, this would be your domain. This would be your get string right here. Whoops, if I don't do that there. So this would be your get string right here. Let's try that again. All right, so we have that. So post is a little different. So it says should report packet analysis capture username and passwords of the post request. Make sure they open the PCAP file for packet analysis. And then you will need a hexadecimal session to clear text. All right, and then you can do follow TCP stream, which we'll do in a second. And then, so here, let me jump a little bit ahead. So these are, so all they did was change this to post. Now I have 3 HTTP requests. If you right click, follow TCP stream. All right, now I have headers. And here's my username and password right here. All right. So this is like a client and server. So this is the request. This is what the server sends back. And then let's see. So now it redirects to welcome, returns welcome. and then it continues on. Alright, so now we're going to do DNS. Now, they're using the port, so you can also do it this way, or you can, so this is DNS on the support number, and if you double click, then you come in here, queries, here's your response. So queries, response, all the way down. Let's see. FTP is very similar. FTP and FTP traffic. Now, note that FTP is unencrypted, so we are doing this unencrypted. Same thing here. You follow TCP stream. Now you have a username, a password. Then with the files, there's a secret.txt that they stored. All right. This, because this is FTP, specifically VS FTPD, we should be able to grab that as well later. So we'll see if they'll let us do that. And then same thing here. So first thing it's going to ask is what directory is found on the the web server for HTTP GET. So now on this one, now it's looking at, so if you look right here, it's actually showing, expand this out a little bit. All right, so you're doing this and you're looking for 200. All right. So, kind of weird that one does not have the oh, huh. Well, I guess there's a this user agent's got a passcode in it, or a flag right here with stage M. It's interesting because on this one, I'm like, I don't see, so I have HTTP right here. I'm looking for 200. I actually don't see a 200. Alright, so what is this? So what we need it's really weird because why do we open this? It's definitely giving me what I want. because the packets don't seem to have the response numbers in them for some reason for me. No, now I have response header. That was weird. Alright then. So for some reason I didn't have these request responses from the server. But now I do. It's really odd. Alright, so I come down here. And then if we find... Alright, so that's go 200, right? I'm going to go and add this as selected. Alright, so I changed HTTP request code equals 200, which is basically valid code right there. So you can actually, so here I actually can search. In here now, although I sorted this. And if you look right here, I mean, it's login, right? So let's see. Put it in here. So you can search by status codes if you're looking for a particular status code. Yeah. Okay. Didn't know slash for it. Alright, what is the username and password used to log onto the page in the number 2 post section? So I'm going to go back up here and go to post. Then right here, and like I said earlier, if you go here to follow TCP stream, and then they want user : the password. So we got this right here. I just want to copy this out. Get rid of this, change this to alright, and then the user agent string, which I saw earlier. So in one, I don't know if it's all, apparently it's all of them, so right here. So if you do copy value, alright, and then the flag is like this. Oh, it wants an 8, huh? Okay. I guess it wants me to check the post. Back to post. Should be the same one, I would think. I suppose it said post, and I just grabbed the first one I saw. Oh, it wants to hold. Whoops. It wanted the whole thing, including the user agent string. Alright, so in the DNS section, there's a txt DNS query. What is the flag message of that DNS query? So, alright. And if you look here, it's going to tell you to go, you look for txt, follow UDP stream this time. So, apparently I'm blind here. Let's see, response. So the other thing here should be able to right here. All right, so the other way, I wasn't sure of the lag, but so type, let's see. So apparently it's type 16. So DS query type equals 16. All right, now we do follow UTP string. All right, and then now you have this right here, maybe. Should be this. All right. And then now the FTP section, what is the FTP logon? So that's pretty easy to do that. Actually, if you look down here, you have user here, password here. Copy value. And put that here. All right, and then in the FTP section, what is this command used to upload the secret.txt? So I pointed that out earlier. So you use store, STOR. All right. Now, what is the contents of the secret.data? All right, and then follow that DC stream here. So if you look, if I follow it, it doesn't necessarily show right here. And what they say to do is to use the FTPD data. So that, and then down here you got the flag here. The other thing you could potentially do is I thought, okay, so for some reason I thought this had FTP, it was only TFTP. But it was HTTP. These are all the HTTP objects files you can download. For some reason I was thinking that they were freaking, you could get FTP stuff there, but apparently not. Enter there. There we go. That completes day 9. All right. And then we're going to do offense is the best defense. Now this one has a virtual machine to it. I'm going to click start the virtual machine. I'm going to scroll up here and also start the attack box. Actually, split screen when it starts. Alright, so it says Miss McSkitty is trying to discover how attackers manage to penetrate the network and cause damage to the best festival company's infrastructure. She decides to start doing a security assessment of her systems to discover how Grinch Enterprise managed to cause this damage. Oh boy. She started by conducting a security assessment of her systems. And one is what services might be exploited. That's just like an Nmap scan. Let's see. Starts firing up. Oh, hey, look. Nmap. And then let's see. We're going to view Nmap and then do that. So you check out Philip Wiley's walkthrough here if you just want to watch his walkthrough. All right. So IP addresses, and that's very true. Every computer needs an IP address, which are If you use an IPv4, there are these dotted decimals. Use an IPv6, it looks something like, apparently nothing apparent at this point. Well, let's go up here. So these are IPv6. So much longer, and to me much harder to remember, to be honest. But that's IPv6. The first IP addresses are private. All right, that's these three right here: 192.168.0.10, 172.16.0.100, and 10.10.11.12. All right, and these are called 18.16. I might get this wrong. Hold me to it. Yep, I got it wrong. Bloody hell. It's like 18. No, 1918. What is it? Yeah. So if I pull up, I was thinking 1819 for some reason. All right, so this is the RFC that talks about private networks. I'm not going to go necessarily all through this, but this explains the ranges. So the ranges are in these right here. So you have the whole 10 range. So 172.16.0.0 to 172.31.25.25. And then you have 192.168.0.0 to 192.16.25, 255.255. Now, generally, this is the one you'll see a lot in homes. This is this 192 range. A lot of corporations will see these two ranges. So, and notice that this is a /8, so this is actually just 8 bits here. This is 12, and this is 16. All right. It goes more into it, but that's where these come from. RFC 1918. And I know I'm gonna get hit on that later, but you know, not reading a lot of RFCs lately. Let's see. Alright, apparently my video is hidden. Well then. Oh, sorry, I don't have, my camera keeps getting hidden when I do that, so we'll just continue and then go from there. Alright. So those are those. This 127 is loopback, or localhost. All right, so ipconfig is on Windows. However, the IP route 2, I think, is a package for this. The new way of doing it on Linux is IP address right here. Or you can use ipconfig, depending on how old your computer is. Alright. And then this uses the 3-part handshake. This is TCP. Alright. And it talks about coffee. That's now it makes me want to go get more coffee. Alright. And then here's all the protocols and port numbers. So these are like doors to a server. So to access a service, you need to know what house they're at by IP address. You also need to know what door they're at as well. So it's It's both. So you have to know both parts. Common port numbers, which are usually from 0 to 1023, are the common service ports. So if you want to go to a web server, it's port 80. If it has a web server set up to it. 443, 110, 25, 22. Of course, this is not usually, that's not normally used. So you know the IP address, which is its address, and then from there, the port number, which is what door in the house you walk in. And that's what this picture right here, that's what it shows. You come from the internet, you hit a server, which port it is, tells you what it's on. Now, Nmap is the program, one of many, but it's the common one, to find out which one of these ports are open. Now, generally, if a server wants to provide a service, they have to have the port open. You should be able to tell it's open. And they're using ST and SS. And Nmap by default checks the most 1,000 common TCP ports. Alright, so you have a connect scan and a send scan. So on the connect scan, if you go back up here, you're going to do this whole handshake right here. On a send scan, you're only going to do half of it. All right. You basically send it. They send you a response, and you go, nope, sorry, I don't want to talk to you anymore, and just go away. Like you don't fully connect to it. Now it looks like we need to run ST. All right. So let's go back over here, and we are going to go split screen. Let me pop this out. All right. First thing we are going to do is run the full connect scan on our vulnerable box. Copy. Oh, the heck? Huh. Let's paste in there. All right. Right, so from here we have 22 and 80, which is SSH and your HTTP. I also have a MAC address. Shows 998 ports closed. How many ports are open? Well, we have 2. What is the smallest port open? Well, if you look at this, you have 88 miles an hour. Let's go back to the future. All right, so you have 22 and 80, so 22 being lower. What service relates to the highest port number? So you have 80 is higher, you have HTTP. So we do that. All right. And let's paste this other one in here. It looks like the same results. So do you get the same results? Sure. Alright. Now you want to detect version information for each service installed. So we're going to use the V flag for version. Actually, this time I'm just going to go over here and do this. So the first thing you just do is just, hey, is there any ports open? As soon as you do that, now you want to find out what information on all those services. Now, some services will give you a header when you connect to it. It tells you what type of software is running. Others won't do that, but they have certain things like the way it responds or certain bits of information that's within the service response or how it talks to you. You can sometimes figure out which service it is. And then what's the version of the website? So you're looking at that and the version number. So it looks like it's this. Oops. All right. By checking the vulnerabilities related to the installed web server, you learn that there's a critical vulnerability that allows allows path transversal to remote code execution. Now, can you tell Muskitty that Glitch Enterprises used this vulnerability? What CVE number of the vulnerability that was solved in the version 4.2.4.51? All right. All right then. So this is the critical path transversal remote code execution and server 2.4.49, which is what we have, and 2.450, which so it looks like it supported two different versions. All right, so one of the things you gotta look here is you have incomplete fix. All right, now and then if you look, that was solved in version 5.1. So fixed in HP server 2.4. I'm going backwards. Oh, apparently it was just right here. So I'm assuming it's this one. I don't know. So this is actually telling us that the fix for CVE 2021-41773 was insufficient. Also direct practice by useful default configurations. These requests can succeed. Alright. So this one fixes this partial or insufficient fix. So let's copy the CVE. So now Muskitty knows which CVE we're talking about. Alright, so you put the piece back together, have a good idea how your web server is exploiting it. Muskitty. Anyway, Muskitty. I hope I'm even saying that right because I'm not even sure. Is suspicious that the attacker might have installed a backdoor. Alrighty then. So backdoor is just another way for attacker to leave the system and then come back. They're usually hidden, not always turned on. There's some interesting nuance of backdoors. Alright, she asked if you could check there's some service listed on an uncommon port outside of 1,000 common ports that Nmap scans by default. She explains that add in -p12655535 or -p- will scan all the ports. What is the common port that appears in the device now? Now, it doesn't necessarily matter which one you use. Technically, S would be faster, so I'm going to use. Now, oops. So you can scan it like this. You could scan it something like, since we already did scan the other ones, right? Something like that. You just scan all of them. It'll all do the same thing. This is pretty fast, so it doesn't necessarily matter, and you only scan in one IP address, so shouldn't take too long, I hope. And then we'll need to know the program listed on that port, so we need to do -v for this. But we'll have to wait for Nmap to finish, and then we'll figure out which port it is, and then we'll scan the particular port. Now, while that's doing that, if you want to help support me or the channel, you can go to the link that I've displayed above. You can always buy me coffee. I'm always up for coffee. Hey, and if you want to send me coffee, you can send me drop me something on either Discord or LinkedIn or Twitter. But find me and say, hey, I'm going to send you some coffee, because I'm always looking for a bit more, better coffee. But if you can't do that, you can always just donate at the link. If you have any questions, I will post the book I talked about earlier, which is this one, and the Operator's Handbook as in the video description when I post this up on YouTube. So if you do have any questions, please ask them on YouTube, on the Discord channel for Cyber Phoenix, or at me on Twitter, however y'all want to do it. So Nmap is an interesting tool. It's the easiest way to map a network. It can be very noisy, so if you're trying to be stealthy about it, probably not the best tool to use. You can run it on your own network to see what tools, what ports you have open on your own equipment. You can also run it on against vulnerable boxes. You see a lot in like blue team CTFs, blue team stuff, and even red team for that matter. I mean, hell, one of the first things you do if you were to take like the junior pen testing exam for e-learning, for example, on their test. I mean, one of the first thing they take you through getting ready for that test is, hey, here's Nmap, here's what you do. This is how you figure out what you're trying to do. So it has a lot of switches to it. Actually, while I'm waiting for this, actually, no, I'll do it over here. So we're gonna go over here. So this book is another book, the Nmap.org book, and it has a whole bunch of options right here. So we did the most common ones, these scan techniques, but there's even a UDP scan you can try. There's these other specialized scans. Depending on if you're trying to bypass like a firewall or some other type of security device, you can use those. Use specifying ports, you can exclude ports. Here's your version information. There's a whole bunch of scripts, and they do some really cool stuff. They're written in a program called LUA. It comes with a whole bunch of them installed by default. Some of these can actually do automatic vulnerability scanning as well. So as you scan for host, it'll then use that script on that host and then give you vulnerability information. OS detection. This was kind of weird. Sometimes it's really odd on the responses you get back from it. Time in, some firewall evasion, more firewall evasion stuff, some output stuff, and then some other miscellaneous stuff. I mean, and just like down here, it's very easy to run, very quick to, well, not very quick, but very few flags you need to get it to do what you want to do. And then, oops. Oh, and it's still going. So this is the this is off the Nmap scanning guide. All right, it's the official guide. All right. Technically, all the information is up on this site as well. You don't actually necessarily need the book to do it, but if you want to get more in depth, nmap.org is a great site to go take a look at and find more information. And again, if you have, any questions, comments, it's just like, Nmap's like, yeah, I'm just gonna take forever, it's all right. Actually, Alright, so alright. So this is a fun part. So I decided to change stuff today. I guess I'd forgotten. I guess T was faster than using S. Kind of makes sense for the full connection. T4 is just how fast it is. Generally, you're going to use nmap-T4, and then the rest of your information. And then right here you have 20, 20, 20, 12, or 20, 212. I play can't talk. Damn it. So, alright. Now, next thing we're going to do is we're just going to scan the port directly because we only need to know that port. So use V for version. Alright, and it looks like it's running until that D. Alright. So let's see. Oops. I mean, I guess I gotta put that IP address in, huh? bestfestival.www. So up here it shows this, but if you notice here, it actually gives you Ubuntu 20043 long term LTS. You log into it. Curious. See another password. This one. Well, you know, worth a shot anyway, right? But anyway, they don't give you user credentials to log into it, but so it looks like T is going to be faster than U. Or not U, but S dash. And again, using S is for the send scan. It's usually not normally noticed, whereas if you do T, which is a full connection scan, it's going to you're going to see that generally. Although don't assume that tools do not see a send scan, or can't assume there's one going on based on the way the traffic's going. But yeah, that's 10, and it apparently took forever for me to realize to change the flag here to T instead of S, which would be what I normally would use. And again, T4 is for speed. So if you look up T. Oops. Oh, come on, really? It's like, oh, I don't want to filter that, apparently. Let's see. So on the time to performance, it's right here. So generally, for most things, going with T4 is fine. Not sure about the field, but for the CTFs, T4 usually is pretty safe to go into. But yeah. So I will put this up on YouTube, and if you have any questions, post in the comments. If you do want to help support the channel, you can use the link on the showing up on the screen. And again, I will be posting links to this book and to the Operator's Handbook, which has the ports and some stuff on it. Obviously, you can look online as well if you want to know ports and filters. The other thing is, like, most Blue Team books will have filters in them. The Operator's Handbook I prefer better because it seems to have more in it and more up to date than like something like this. You have the Blue Team manual. But I'll post links to all that, and then you can, if you want to grab them, you can. I would highly suggest grabbing the Operator's Handbook, which is the yellow one, which I don't have on my desk at the moment, but I will post a link. And again, happy hacking, happy holidays, and I will probably be back to do 11 and 12 together, since I prefer to do them kind of a little bit together. Don't get a lot of time, but if you have any questions, post in the comments or on Twitter.